Hello friends, welcome back to our Associates. In the last tutorial, we have solved 95 concrete frames which failed in design check. As a result, today you can see that all concrete frames passed the design check. But I always say this is just the beginning, yet long way to go. So go to design, concrete frame design, display design info. Then from here you can check longitudinal reinforcing, rebar percentage, shear reinforcing, but here we are just trying to find out the failures, so we will go for column PMM interaction ratio. There have no issues with this thing. Then go to column beam capacity ratio. Column beam capacity ratio, this is almost fine. From here you can just see the column, so go to select, then select object type, then from here you can select column, okay, or you can also select the column beam, select object type, columns and beams, select, close, show selected objects only, okay. Now you can go for column beam capacity ratio, okay. If this shows you any OS, in that case you have to understand that there have some problem, okay. So next we will go for joint shear capacity ratios, okay. Then we will go for general, okay, identify PM failure. Here you can see there have some problem, that means it is showing that these two columns are overstressed, okay. Then we can go for identify shear failure, okay. Also this column is OS this time. Finally we will go for identify all failure. As a result, we can see all types of failure which are present is still present in our structure, okay. So click on OK. From here you can see that this column is failed in PMM interaction ratio, also this column. Then there have issue with this column, that let me select or show you properly. From here you can turn offset grid system visibility. This column have some issue with joint shear capacity, okay. Also, okay, that means these three columns have some issues, okay. This 1, 2, 3, okay, these three columns has some issue. Let's try to find them in the plan view, okay. So from here select all stories, this column, all stories, select this one, okay, this is the one which we need. Then this one, okay. From here I am trying to select all stories, then select this one and also this one, okay. Now what is the position of this column, we have to find out, okay. It is this one, okay. So from here select all stories again, and now what we have to do? Actually, we have to increase its dimension or section, whatever you say, or we can try by changing its orientation, okay. But here I will go for increasing its section at first. So unlock, then you can select these three column again, because this time we already know that this one is, and this one and this one. So go to assign, go to frame section property. From here I am just simply assigning 15 by 40. You can try with the lower sections, okay. But though I am making here a tutorial, just I am showing you the procedure here. So click on apply, okay. Now analyze the structure again. Here you can show all objects, then go for analysis. So you can see though our structure has passed Okay, that means all concrete frames passed in design check, but that was not the final dimension of our column. Still, we are working with the increased column dimension, or we are trying to find out the best column section. Okay, now go to design, concrete frame design, start design check. Okay, now design, concrete frame design, display design info, identify all failure. Let's go to select object type, column, select, close, show selected objects only. Still these problems, still we can't solve this problem, but we have solved joint shear failure issue. Now what will I do? I will change its orientation. I will give a try by changing their orientation. So from here I just don't need to see their section and labels, etc. So from here I will just okay, from here just click on show on deform shape. From here select all stories, select this one, also this one. Okay, this time I will go to assign frame, then go to local axis, then here change the angle by 90 degree. Okay, but if we do so, in that case the situation is this beam is going out of the grid. Okay, so there have a easy solution. Just select this one with all stories and also select this one with all stories, then delete them. Okay, now go to quick draw column, then from here select column size, that means 15 by 40, then draw this one at the center of the beam and also at the center of the beam. Okay, now from here select one story, just go to the base initially, apply OK. From here select all, assign, joint, restraint, fixed support, apply OK. Now check the upper floors. Okay, that's fine. Now analyze the structure again. Now go to design, concrete frame design, start design check. Okay, go to design, concrete frame design, display design info, identify all failures. Okay, that means this column is still failing in design check. So unlock the model, go to define, then we can define another section. This time you can take copy from this one, add copy of property. Let's make this 15 by 45. Okay, naming this one as C 15 by 45. So click on OK. Click on OK, select here all stories, then select this one, then go to assign, frame, section property. From here select C 15 by 45, click on apply, OK. Now analyze the structure again. Okay, go to design again, then concrete frame design, start design check. Still there is OS. Okay, still there is OS. So we will give a try by changing its orientation again. let's select this one. Okay, let's select all stories from here. Then from here select this one, go to assign, go to frame, then go to local axis, and from there change its orientation, click on apply. Okay, we don't need to see the local axis, so click on show undeformed shape, then analyze the structure again. Okay, now go to design, concrete frame design, start design check again. Hopefully this issue has been solved. Now go to design, concrete frame design, display design info, identify all failure. This time you can see that there is no any failure. Okay, now we will go for shear oval design. So at first unlock the model, then from here we can see all objects, that means show all objects. From here you can select set 3D view. Okay, now go to select, then object types. From here select walls, select close, show selected objects only. Okay, now go to previous selection. From here you can see that ETABS selected all the shear ovals, but it has also selected waste slab, which we don't need to design here. Okay, so go to select, then go to deselect. From there go to properties, then slab section, then waste slab, and from there click on deselect. By this way you can see it has deselected all the waste slab. Now close this one, then go to design, shear oval design. Then you can check the view / revise preference. Here we are completing the design by using ACI 31814. Then click on OK. Then again go to design, shear oval design. You can go to, now you have to go to the assign pier section. From there select uniform reinforcing. Here I am interested to use the concrete strength 3500 psi, and from here just select spacing as 8 inches. That means bar to bar clear distance will be 8 inches. This is the first trial. If this fails, then we will decrease the spacing. Okay, then click on OK. Here reinforcement, keep this one, that means reinforcement to be checked. Then click on OK. Now go to design, then go to shear wall design. Select design combination. You have to select all the 23 or the total load combinations you have. If they are at the left side, select them all and send them to the right side. Click on OK. Now go to design, shear wall design, start. Sorry, we can't start design check. At first we have to analyze the structure. Okay, now go to design, shear wall design, start design check. Okay, now let's start checking from the bottom. Right click of mouse, This portion is okay because here demand capacity ratio is less than 1. Okay, so there is no warning for this portion. Then go to this side. At this portion also demand capacity ratio less than 1, so there is no warning. After that, go to this portion. Okay, there is a warning. That means for this portion, shear wall fails in design, because here you can see demand capacity ratio is greater than 1. Okay, so ETABS are showing us a warning that design inadequacy message, pier fails in flexor or PMM interaction. That means here we have to increase the vertical reinforcement. Okay, so from here I am selecting all stories. Then from here select this one, not being selected because there have some variation in the property. So from here select all stories, then this one, let me rotate this one. Okay, again all stories, select this one. Okay, all stories, we are just selecting this part. Then from here go to design, shear wall design, assign pier section, uniform reinforcing. This time we can choose spacing at 5 inches. Okay, then go to design, go to shear wall design, start design, check. Okay, let's check again. Right click of mouse, select this portion, right click of mouse. This time you can see that demand capacity ratio is less than 1. As a result, there is no warning. Okay, now no need to check floor wise. You can go to option, then you can go to design, then shear wall design, then you can go to display design info. From here you can select identify all failure. Okay, you can see that this portion is overstressed. Very fine. From here select this one, and right click of mouse. This is saying that, okay, same warning. So from here I will just select all stories, then I will select this portion and this portion. Okay, let's make a try with design. Okay, let's check what is the demand capacity ratio here. Here demand capacity ratio is around 1.04. Okay, let's make a try. All stories. From there select this portion and also this portion. Okay, then go to design, then shear wall design, assign pier section, uniform. This time choose here 3 inch spacing. Okay, then click on OK. Now go to design, then shear wall design, start design, check. Okay, let's check. Yes, this time there is no warning. Now go to design, shear wall design, then again go to display design info. Let's check again whether there is any failure or not. This time you can see that there is no failure. Okay. Now I will show you how we can design a spandrel. Here it is not showing us a spandrel design because we didn't provide any spandrel labels. Just go to define, then spandrel label. From here you can basically ETABS will give you one spandrel label by default. Name it as 2, then add new name, as much spandrel ID as you need. Here I am just clicking OK. Now select any spandrel. Here I am selecting this one, suppose. Then go to assign, then go to shell, then go to spandrel label. From here I am naming it as S1. Okay. So go to design, go to Shear oval design, then go to start design check, but before that you have to run analysis. Okay, at first from here check that either they have any overstress issue or not. So from here go to display design info, then identify all failure. Yes, there is no failure. Fine. Now let's check longitudinal reinforcement of the spandrel. Here you can see the longitudinal reinforcement. Okay, then from here you can see shear reinforcing. You can check the shear reinforcing from here. Okay. Now you can check diagonal shear reinforcing. Okay. By this way you can design spandrel in ETABS. That's all for today. See you in the next tutorial. Thank you.